The final topic we're going to look at for this unit is graphing linear inequalities. So we saw inequalities with one variable that we graphed on a single number line. Now we're going to see inequalities with two variables that look like a line, and we're going to graph it on a coordinate plane. Which leads into our essential question, how do we graph inequalities on a coordinate plane? We'll look at different forms for the inequality, just like we looked at different forms for equations of lines. Our first one is in slope-intercept form. We'll start by identifying the slope and the y-intercept, just like we did when we were graphing the line. Our slope is what we're multiplying by the x. It gives us rise over run. Our y-intercept is what we're adding or subtracting, and it gives us our starting value. We'll go up 3 on the y-axis for our y-intercept, and we'll rise to run 1. Again, I like using the whole graph. We can also fall to and go to the left one to continue our line. One of the most challenging parts of graphing inequalities on a coordinate plane is remembering to check to see if the line should be solid or dotted. A solid line would be like if we had a closed circle on our number line. It's the or equal to. It means every point on our line is a solution to the inequality. So we have a solid line on this one. A dotted line would be if we had just greater than or just less than, and the points on the line do not make the inequality true. It would be like having an open circle on our number line. And just like on our number line, we will shade part of the coordinate plane to identify all of the ordered pairs that will make this inequality true. To determine which side of the line we shade on, we pick any ordered pair that is not on the graph. If our graph doesn't go through 0, 0, I always pick 0, 0 because those are easy numbers to work with. So I substitute this ordered pair that I chose in for x and y. Y becomes 0. Is it less than or equal to 2 times 0 plus 3? If it's true, we will shade on the side with 0, 0, or with the point we chose. If it's not true, we shade on the other side of the line. 2 times 0 is 0, 0 plus 3 is 3, and 0 is less than or equal to 3, so we will shade the entire graph that includes that point 0, 0. Remember, what that means is any point in that spot that's shaded would make this inequality true. Our second example is also in slope-intercept form, so we'll identify that slope. This time our slope is negative, so it means our line will fall. Our y-intercept is -4. That gives us the place that we start on the graph. So we'll go down 4 on the y-axis. I will fall 2 and run to the right 3 to make sure that my line falls. Or I can rise 2 and go left 3, again making sure that my line falls. Check to see if your line should be solid or dotted. In this case, we have y is just greater than, not or equal to. So we will have a dotted line similar to an open circle on our number line. Choosing a point not on your line to determine which side of the graph we should shade on, I'm going to replace both x and y with 0 to see if 0, 0 will make my inequality true. If it does, I will shade on the side with 0, 0. If it does not, I will shade on the other side. My -2/3 times 0 cancels, and I'm left with -4. Is 0 greater than -4? The answer is yes, so I will again shade on the side with 0, 0. Next, we'll take a look at standard form. Remember when we graphed standard form, we found the x and y intercepts. So I'm going to find the x-intercept of this line by replacing y with 0, -3 times 0, and I'm going to put equals 6 because we're finding where this graph crosses the x-axis so that inequality doesn't really impact the intercepts. Dividing both sides by 2, I get x equals 3. Remember, writing that as an ordered pair, I solved and got 3 for x when I substituted 0 for y. Finding that y-intercept, I will replace x with 0 and solve for y. The 2 times 0 cancels, so I'm left with negative 3y equals 6, and I'll divide both sides by negative 3 to solve for my y-intercept. I substituted 0 for x, and I solved and got negative 2 for y. Plotting those points on my graph, I have 3, 0, and 0, negative 2. This line will again be dotted because it's just less than, it is not or equal to. So we have a dotted line through those 2 points. I'll pick 0, 0 to substitute in, replacing the x and y with 0. We'll see if this is true. 2 times 0 is 0, 3 times 0 is 0, 0 minus 0 is 0. Is 0 less than 6? Yes, so we'll shade on the side with 0, 0 again. One last example. Solving for the x-intercept, I replace my y with 0. We can change this into an equation while we're solving for the intercepts. 5x equals 20. Dividing both sides by 5, I'll get an x-intercept of 4. Writing 4 for x because I substituted 0 for y. My y-intercept will be when I replace my x with 0 and solve for y. 5 times 0 cancels, so I get 2y equals 20. And dividing both sides by 2, I get a y-intercept of 10. So I will write that as an ordered pair. I substituted 0 for x and solved to get 10 for y. Plotting my intercepts, I had a positive 4, 0 for my x-intercept and 0, positive 10 for my y-intercept. This line will again be dotted. It's just greater than. Picking out 0, 0, substituting it for x and y to determine if it makes the inequality true. 0 plus 0 is 0, and is 0 greater than 20? This time the answer is no, so we'll see what happens when you get an answer of no to your question. We shade on the side of the line that does not include 0, 0. And you have 2 you-try questions today, one in slope-intercept form, and I'll warn you about number 1. This line does go through 0, 0, so when you check for your shading, you will have to choose a point that is not on the line, so you can't choose 0, 0 for that one.